Okay, so as you can kind of tell, taking these derivatives using the limit definition is quite a long, tedious way to go through and find the derivatives. So, some people a long time ago said there had to be a better way, and they sort of studied these things and kind of came up with some basic rules that we can use to help us take the derivatives quickly. So the first one that I want to talk about is the constant rule. So if you ever have f of x is equal to c, so c could be a constant, any number, 2, 5, a fraction, a negative number. Remember that the derivative always represents the slope of the tangent line. It represents an instantaneous rate of change. And so if you want to sort of think to yourself, well, how much does a constant change? Not at all, right? So that means that the derivative is always going to be 0. So if you ever have a constant, if you ever have, a number, the derivative of that number is always going to be 0. Okay. Another really common rule that we use is the power rule. So the power rule sort of is whenever we have functions of this form. So there's x, the variable is in the base, and p is going to be a constant in the power. So p can be anything except 0. So x squared, x cubed, x to the 1/2. All of those ones are ones where we can use this power rule. And the basic idea of power rule is you're going to bring the p in front, okay, and then you're going to subtract 1 from the number that was in the power. And if you wanted to know why this rule is true, you can go back to the limit definition and work out why this is the derivative. It's not just some rule that someone said is true. It's true for a reason. You can prove that this is actually the derivative. So let's just kind of practice here. If I gave you f of x is equal to the square root of x, I think in my previous video we went through and found the derivative using the limit definition, the really long, tedious way with the limit and lots of algebra. But let's figure out, what this would look like if you were going to do it the shortcut way, right? So you might want to rewrite this. So the square root of x we can rewrite as x to the 1/2. Now, if I were to go through and work out the derivative here, I would use this power rule. So my p in this case is 1/2, so I'm going to move the 1/2 down. The x stays the same, and then I'm going to take that 1/2 and subtract 1. Now, we might be able to simplify this a little bit, so we'll have 1/2 x to the 1/2 minus 1 gives me minus 1/2. And I think it would be totally okay if you left your answer there. That's the derivative, 1/2 times x to the minus 1/2. But just so it can kind of match up with what we did in the last video, we could also take this and rewrite it as 1 over, and then the 2 is going to stay on the bottom because it was part of the 1/2, and rewrite this as x to the positive 1/2, right? That's what we do with negative exponents, which we could rewrite as 1 over 2 square root of x. And I'm confident that that's the answer that we got in the previous video when we derived it using the limit definition. This way is a little bit faster. So just make sure you pay attention. If they say to use the limit definition, you have to do it the long way. But if not, you might as well use these shortcut rules. And I encourage you to spend some time practicing this week and this weekend at getting fast at doing these rules, because they're going to, in 21A, expect that you kind of know them. So they will go through them again. It sort of depends on the professor. Some professors make this assumption that students know how to take derivatives already, which is not necessarily true, but that's what might happen in some people's classes. And some people go through them pretty quickly. So we'll kind of see what happens next quarter. Anyway, moving on. So the next one is the constant multiple rule. So this is if I have some constant, any number multiplying a function. Okay. So if that's the case, then you're just going to go through and you're going to do that constant times the derivative of the function. Okay. And we'll work through an example with that in a second. But first I want to talk about what happens when two functions are adding or subtracting. So I put the adding case here. Maybe I should have put the subtracting case as well. F of x is equal to some function g of x, subtract some other function. This kind of is a nice one because in this case, we can just do the derivative of the first thing plus the derivative of the second thing. Or in the case if they're subtracting, we'll just subtract the two derivatives. It's really nice when we can do it this way. Okay, so let's do a little practice here. So let's start with this function, f of x is equal to 5x to the 4. So let's break this down. There's a constant in the front, that 5, right, times a function here, the x to the 4, right? So this thing here sort of meets the criteria for this constant multiple rule because we've got a constant in the front and then some other function beside it. So if that's the case, if I want to go through and find my derivative, oops, wrong line. I'm just going to do 5 times the derivative of x to the 4. Now x to the 4 has a variable in the base, number in the power, and so that's our power rule. So you would move the 4 in front, and then x, and then 4 minus 1, which we could simplify this thing. 5 times 4 gives me 20, x to the 4 minus 1 gives me 3. And with lots of practice, I hope that you might be able to skip that first step and maybe move quickly. But for the first little while, as you're sort of starting to learn this, it's okay if you need to write out some more steps to get there. All right, so let's try this next one. This is about as tricky as they get. So if you want to give this a shot on your own, pause the video, try it on your own, and then we'll go through it together. So to take the derivative of this one, okay, we've got 3x to the 4, so we're going to have 3 times the derivative of x to the 4, and the derivative of x to the 4 is 4x to the, subtract 1, 3. And then we've got this weird fraction, but that's just a constant in front of that x, so we've got 8 over 3 times, and then the derivative of x, okay? You could think of this as, this is really x to the 1, right? And so you can move that 1 down, 1x to the 0. Now, x to the 0 is just 1, right? So this part is going to kind of go away and just become 1. Now, the derivative of the minus 5, this was the thing we talked about at the very, very beginning. If you ever have the derivative of a constant, how much does a constant change? Not at all. So the derivative is going to be 0. And we might want to simplify this a little bit. So we've got 12x to the 3 plus 8 over 3 times 1 plus 0. So again, with practice, I hope that you'll get so that you can get to that second step quite quickly. But if you need to write out the steps in the meantime, that's okay too.